Welcome to GK TechVerse. Welcome. One of the most important multi-threading interview questions is, what is deadlock in Java? Deadlock is not just theory, it's a real production issue that can freeze entire systems. Deadlock happens when two or more threads wait forever for each other's resources. In result, they just freeze, no error, no response, system just hangs. This situation in Java is called deadlock. And today I will explain it in the simplest way possible. In this video, you will clearly understand why even we need logs, how deadlock actually happens internally, real enterprise examples like banking and ticket booking, bad code versus good code, and most importantly, how to prevent it in interview and real projects. Before we talk about deadlocks, we have to understand why do we need locks and what is the race condition. Here we'll take simple scenario from real enterprise banking application. Imagine your bank account has 1000. You go to an ATM to withdraw rupees 200, and at the exact same second, in the same time, your automated utility bill pays rupees 300. Here, in this case, ATM withdraw and utility bill pays, these two are two different requests, means these two threads are accessing your balance, which is shared resource. Without a lock, here is the disaster. Both the ATM and the bill service read your balance as 1000. The ATM calculates 1000 minus 200 as 800. The bill service calculates 1000 minus 300 as 700. The ATM saves 800 to the database. In a milliseconds later, the bill service saves 700 to the database. The result, your 200 withdrawal just vanished into thin air because the second update stepped on the first one. The bank loses 200 and you have a mess on your hands. This is why we use locks. We force the bill service to wait until the ATM is completely finished. It ensures that the second service reads the updated balance of 800, not the old 1000. So to avoid data inconsistency issues, we use locks. But sometimes locks themselves creates a bigger problem. If you do not handle lock properly, then we will face deadlock issues. We'll see that issues with real-time scenario. We discussed when multiple threads are sharing common resource, we should lock to avoid data inconsistency issue. Let's look at a classic interview and real world disaster. This happens when we have two separate accounts. Let's say customer A and customer B. Thread 1 is trying to send money from customer A to customer B. In the same time, thread 2 is trying to send money from customer B to customer A. Here, the first request is customer A to B. At the same time, customer B to A, there is a money transfer is happening. So here is the flow of the crash. Thread 1 grabs the lock for account A. Thread 2 grabs the lock for account B. Now thread 1 is reaches for B, but thread 2 is holding it. So already thread 2 is locked B, but thread 1 is trying to lock B. So here thread 1 is waiting. Simultaneously, thread 2 reaches for account A, but thread 1 is already holding that. So thread 2 is waiting. See the problem? They are both holding one key and begging for the other. This is the circular wait. Neither can move, neither will let go. That, my friend, it is a deadlock. So if you are not using locking properly, you will see deadlock issues. Now what is the solution? We can resolve this issue by locking in order. So in the real world scenario, The big applications will use locking in order to resolve the deadlock issue. We'll see that. So in the real world scenario, the big applications will use locking in order. So in this scenario, so instead of locking based on who is the sender, we lock based on the account ID. We tell the code, I don't care who is sending money to whom. You must lock the smaller ID first. Now, if both threads try to transfer at once, they both race for the same first order, the smaller account ID. So we have to lock in the order. One thread wins, the other thread waits outside. No one is holding and waiting on a cross lock. It turns a circular collision into a straight orderly line. So remember, locks are necessary, but wrong usage cause deadlock. In interview, always explain real example, bad flow and good flow. That makes you stand out. So let me show you the code. So here in this example, so we have created a without lock inconsistency scenario and bad lock deadlock scenario and good lock good order to prevent the deadlock. So if you see this without lock, so here what we are doing, we have a two accounts having balance and so we are transferring the amount to each other without a lock scenario. We are not doing any lock. Okay, so there will be a inconsistency, right? And the second scenario is if you do bad locking, means so this method, so we are doing the lock method. First we are locking the sender, who is the sender, so we are locking that sender and receiver. So always, like if you see in this case, A to B the amount is transferring and B to A we are transferring. So always what we are doing, first we are locking the sender and trying to lock the receiver. So in this case we will get a deadlock issue, right? So the good approach, if you see good order, no matter who is the sender, right? So here we are trying to lock first person, right? The in a lower order. So what we are doing, first lock always we are doing. So who is having the lower ID, that person will be the first lock and it will come to the second lock, right? By this way, we can resolve the deadlock issue. So this is the sample code. So I am attaching the Git reference. You can check this. So you need to remember deadlock occurs when these four conditions exist: mutual exclusion, hold and wait, no preemption, circular wait. Interview points you need to remember: threads wait for consistency, deadlock due to circular wait, lock ordering prevents the issue, deadlock happens due to wrong locking design. Thanks for watching GK TechVerse. Subscribe and keep upgrading your skills. See you in the next video.